Did you ever ask yourself how was chosen the distance to define 1 meter? It's all about triangulation on maps and all the mathematics stuff. But before beginning, let's take a look to the general notion of cartography. Cartography is the science and art of creating maps, which involves the depiction of geographical features and spatial relationships between objects. Maps have been used for centuries to facilitate navigation, military operation, and also trade. Mathematics plays a crucial role in the conception of cartography. It provides the framework for accurate measurement, representation, and analysis of spatial data. Mathematical concepts such as geometry, trigonometry, and calculus are used to create accurate projections of the Earth's surface onto a two-dimensional map.
Thus, the development of standardized units of measurement has been a significant part of human history. One of the key applications of units of measurement has been in cartography, where accurate measurements of distances and areas are essential. Until the 18th century, there was no unified system of measurement, despite the attempts of Charlemagne and many kings after him to reduce the number of existing measures. France was one of the most inventive countries in this field. There were more than 700 different units of measurement in France. Many of them were defined by human morphology, such as the finger, the palm, the foot, the cubit, the step, the fathom, or the toes, whose Latin name designates the extension of the arms. But they could also vary according to the region. The foot was not the same everywhere in France, which complicated trading.
In the late 18th century, during the French Revolution, the French government sought to create a new system of weights and measures that would be based on rational principles and universal standards. This led to the development of the metric system, with the meter as its fundamental unit of length. To determine the length of the meter, the French Academy of Sciences, composed particularly of Lagrange, Laplace, Monge, and Condorcet, sent out a team of scientists, including Metre and Delambre, to measure the distance between Dunkirk and Barcelona, which was to serve as the basis for the new unit of length. Metre and Delambre used the technique of triangulation to measure the distance accurately. Triangulation involves measuring the angles of a triangle formed by 3 fixed points to calculate the distance between those points. Metre and Delambre used instruments such as the measuring chain and the repeating cycle to make precise measurements.
To find out the distance between the two cities and with the use of those instruments, Metre and Delambre placed on a map noteworthy points such as towers and churches, and by simply creating imaginary triangles between those points, they were able to connect Dunkirk and Barcelona with no more than 100 triangles. The triangulation method helped them to determine the length of each side of the triangles. It basically consists to measure 2 angles of each triangle, and by the knowledge of the length of one side, they were able to calculate the other side. And so, by having all the length of the 100 triangles, scientists were able to define the distance between Dunkirk and Barcelona, the axis of the meridian needed to define the meter. The standard meter was then created and represented 1/10,000,000th of the quarter of this meridian.
However, the measurement expedition was not without challenges. They encountered harsh weather conditions, inaccurate measurements due to the lack of standardization of measuring instruments at the time, and political unrest in the areas they had to cross. Metre was even briefly imprisoned by the Spanish authorities on suspicion of espionage. Despite these difficulties, Metre and Delambre successfully completed their mission, and the length of the meter was established based on their measurements. The meter was defined as 1/10,000,000th of the distance from the North Pole to the equator, passing through Paris.
The definition of the meter has evolved over time, with the current definition based on the speed of light in a vacuum. The current definition provides a precise and universal standard for measurement of the length. All the world except in few countries such as the United States, which still use feet and yards to define distances, have now a full metric system with which weight, volume, and other physical quantities can be defined. This universal system allows people around the world to trade fairly, to understand each other, and to create a common science language. This is why the distance of meter is 1 meter.